And what we'll do is, I'll show you this on Tinkercad, okay? This is a real simple sort of lab. See if I can get Tinkercad.
No, and likewise, I could apply 12 volts just that I have on.
Well, for some reason, the computer's just giving me this spinning beach ball of death because I rebooted it, so I'm being punished. But this is the
This is for program. This is like 5. You don't worry about too much current. If you try to drive a bunch of them with one Arduino, we only have one strip so far. And you run into some struggles just with the simultaneous.
5 volts and ground.
Use like actual LED drive.
Go into your servo.
Chips that have like 6 connections with different LED strips.
And then you want to have pin 9 driving the servo's pulse width modulation. What I'll do if I can get this browser to run.
No. I have a big group together. Oh yeah, good people. Oh yeah, good job, guys. So is it the quarantine? I think that people just show it.
All right, everybody should get a servo from the back, and get one of the sensor shields as well. I think that'll make things a little bit easier.
Oh, there are more of these. Okay, what are these for? Hold up. We have more, we have male wires that I just didn't find last lab. So you don't really need that sensor shield.
Well, why don't you try it?
If they have male-to-male wires, do you want them to use it?
Well, I was just going to say, why not try the sensor shield?
Okay. Alright. So use the sensor shield, that will plug right into it. You're going to need still these male-to-males. Actually,
it's female to female, I think.
well, the servo has
okay,
female, this is male, so you should be able to plug a servo right into that.
Yep. That's right.
Yeah. So they can plug right into these rows. So this is going to plug into your Arduino. It's going to sit on top of your Arduino, and then it's going to plug into any. Let's see. So you see here, all servos and fans and stuff like that that are 3-wire have the same pin out. It's ground, volts, voltage in, and then your signal. So that's why these shields work, because all of those 3-pin things are ground, on ground, voltage in the middle, and then signal. So you just plug it right into that, and that's the same as if you plugged it into a digital. So you see how there's these numbers. So this shield, the way that this works is if you plug it into 4, those 3, that's going to D4, your digital pin 4. 4, okay? So yeah, so don't use one all the way on the left, sorry, just each one of these rows goes to one of the Arduino pins, and this one goes to A ref, but you want it to go on the actual pin. Not the most left one or the second most left one, not those. I would put it somewhere on one of these 2 middle ones. Those are so the first couple of digital pins have special functions usually, unless you need those. Just stick with the other digital pins. Not that like it'll work, but then later if you're like, oh, I want to do this special thing with one of those, then you'll have it there.
All right, so I'm using example code for pin 9. If you're using a sensor shield, you want to go to row 9. When you see G, V, and S, G is for ground, V is in the middle, that should be your 5 volts, and S is going to be your signal, and you'll go on to row 9, and that'll save you from having to wire DuPont cables to 5 volts ground, and then pin 9. If you don't have a sensor shield, you can just wire it up as shown, just like this. as far as the code is concerned, the only thing you have to do today, and I know there was a two-part thing in the PowerPoint, let's just keep it simple, keep it to one part. All you have to do is this code right here. It is a real simple program. I don't know if you can see that okay. But in any case, it basically says include servo.h. I set up a servo called Servo 9, and then I attached it to pin 9. And then I do a for loop that goes from 0 to 180. I write out the position, so the position's in degrees. And then I hit a delay of 15 milliseconds. Then I do a servo write of 0, which rewinds the servo to the beginning, but that takes time. So I give it a delay of 2 seconds, and then I start the loop again. And that's it. Take a picture, take your code, full code, complete code, put it into a Word document, upload it, and bang, you're done. And we're going to call that lab number 3. That'll be due at the end of the day next week. You got another lab due today. I think they're calling it lab number 2, which comes right before lab number 3, oddly enough. And that is the lab. Now I can do the demo. So here is a sensor shield with an oversized servo. Your servos don't have to be this big. I'm using a larger servo because I plan on doing something real specific with it. So here's the servo. This is a larger servo, gives you a little bit more oomph. And I'll just hook it to this little battery. And now it's going to start to turn. But then it looks like somebody messed up my program, so I got to upload a new program for this one. Bummer. Then what I did was I put a little parabolic dish on the end of the servo so it will scan. And then on the end of the parabolic dish, I put a little tiny ultrasonic sensor with a standoff, and I just screw it in, and that'll sweep the ultrasonic sensor around and give you a proper focusing of the sensor, so you get a better angle, let's say angle of acuity angle. And that's it. The whole thing was built on a solar-powered cigarette lighter with a paint can top, and this is a little nylon quarter by 20 female thread, and then in the center there was a hole for kind of like this pokey thing that came out to hold your cigarette. And what I did was I took the pokey thing out because I'm not smoking, and I put in some construction adhesive and seated in a 2mm standoff receiver so that I could use the sensor's existing hole. The existing holes on these sensors is 2.5mm. 2mm is just perfect for this. But if you're ever going to try and mount your Arduino, you need M2.5 or M3, no larger than M3, or you won't be able to get through the holes without cracking the printed circuit board. M3 is 3mm. So that's the shtick. My demo didn't pull off because I got to re-upload my code, but that's life in the big city. I gave my Arduino to somebody and they messed it up. That's normal. If you're using the sensor shield like I'm using here, and I'll hold this up for the Zoom folks too and pass it around in case you want to see it. My sensor, my servo has yellow, red, and black as the color code. Red and black are going to be your power and ground respectively. Red's in the middle. And then the yellow is being used for the PCM, the PWM. So the pulse width modulation comes out on the yellow. Your colors will be different. I think they're brown, orange, and something else. What is it, red?
Yeah, red.
Is red in the middle?
Yeah.
So red's going to be your signal. I think brown is going to be ground.
It is, yeah.
Yeah, so brown is ground, red's a signal, and then the other one's going to be your, how you say, signal, yeah. So then, if you're using Sensor Shield version 4.0, it'll look just like this. There's a new Sensor Shield. It says on the silk screen 5.0, and we had a little trouble with that earlier today, and I'm not sure why. Either I don't understand how they work, or something's wrong with them. I don't know. I buy them on eBay, so you know the quality is good. So that's the upshot of all these things. When you get them on eBay, they come really cheap, assuming your time is worth nothing. So that's that. Let's see who's sitting around on. It's Joshua. Joshua, is that coming through okay? You got any questions?
No, I'm good.
You good? Okay. I'll just hold this up so you can see it. You can see that okay now, right? That's the sensor shield. If you choose not to use this, and you don't have to, you need a couple of DuPont wires in order to wire up a servo. But if you can't do that and you're not coming in, you can do the whole thing with simulation using Tinkercad, and that's just as good. So if you want to use Tinkercad, just do what I've got up here on the screen, and you should be all set. Give us a picture and give us your code, put it into a Word document, submit your assignment, and bang, you're done. So that's your that's your distance learning option. What do you think of that?
Sounds good.
Good, good. Hey, by the way, you're the only one on Zoom right now, but don't take it personally.
Nah, I'm not near campus right now, so I just had to.
It's totally okay. It's policy. You guys can be home if you want, but for my money, I'd rather come in and have a hands-on organic experience with the hardware. It's just,
Same, it just didn't work out.
yeah, it's all right. Don't worry about it. So we got from the two sessions, one person doing this. Is that what we're doing? And the first person, there was nobody on distance learning on the first session. The second session.
Does that mean that we're missing people?
I think so, because I thought we had like a good showing in the first session.
Or that's all.
Yeah, but aren't there like 18 in this class?
15, 17. How many people? I guess we are missing people. I don't know.
6, we can have 11 in the
It's
first
working.
class. Yeah, is this all we have to do?
That's it. You got it. I just wanted to see you guys make the servo work. Is it?
It's a little broken. It's like it's stuff when you.
Oh, it won't do it full 360.
Okay, it's not doing 360. Just
You got it. You got it.
right. It's a little slower.
Yeah, that's just crappy servo.
It is a crappy servo.
Yeah, those little 9-gram ones are like 50 cents.
Well, what happens is people hold them and they strip the gears.
Yeah, and they skip and stuff.
Yeah, I mean, it's like nylon gears get. See, these have actual metal gears
Okay,
inside.
now?
Yeah, that's what those
The
are.
higher end servos are. I have a day and night difference, you know? Yeah.
Program it to like a certain pin.
Yes, you can change the pin. So when you attach pin 9, you hit row 9. If you want to attach pin 8, then you have to move it over to the next row. And so what's cool about that is you can have multiple
The
servos.
pin numbers are on here, the pin that they correspond to. So you see that your analogs down there, and then these are your digital pins. So if you want to get
So, for that,
little
Yes.
transmitter, you can use like,
Oh, thank you.
well, first of all, that's the continuous rotation
So this is-
circle. So,
Okay.
so I know the
if you
process
want,
is-
the loop can be bigger. This loop is
No, I'm asking where's the pin?
The servo got attached.
It's one.
Yeah, so the servo library is gonna basically do all that stuff, for you, like the usual like pin mode and all that stuff. The servo library does that. So you say my servo
Get my
got
glasses and I'm going to check. Maybe that's why it's not working.
I think it's alright.
I got it on row 8 instead of row 9.
I think so.
You might be
And
right.
again, you do whatever you want down there.
Oh,
You can-
yeah.
you
How
can
about-
report the position on the serial monitor if you want to, so that you do.
So I put it on
servo
row 9 and then-
position is as it goes
Is
around.
that it?
Yeah, do you know how to use the serial monitor? So put in setup.
Gee, you're absolutely right. It's on row 8.
In your setup,
Then
down below servo dot attach.
I did it.
Yeah, but within the loop, so line up, yeah. Just say like, serial dot begin.
Yeah, here's one.
Not yet.
If I do row 9 this way.
9600.
Oh, it's working now. Ah, it's all about getting the right row. How about that? Okay.
Yeah, take it at that space right there. Yeah.
Okay, Josh, you can see it now. Here we are scanning with the little parabolic dish. So this is my cigarette lighter sweeping around. Now the next step, of course, is to hook up the ultrasonic sensor with my cobbled together. I just did the gluing last night.
And then parentheses.
So that's it?
Or sorry, serial dot print. My bad. Serial dot print.
If you want to, you can add some more servos and play around with it, because your code is set up for only one servo on row 9, but you could add a servo to row 8 and a servo to row 7, and you know, once you got your servos running, there's all kinds of things you can do. Okay, there it is with the ultrasonic sensor attached. So now we can scan in 3D. We have a 3D scanner, and it will, I guess it's a polar coordinate scanner, right? Polar coordinate. So it's giving you angle and magnitude, and that's cool. Angle and magnitude.
And the serial monitor.
So that's the shtick. We know how to work the sonar, the servo, and the ultrasonics, and that'll give us the ability to do some interesting stuff.
Statement that says, like, yeah, this position is, or whatever, like, it's turning in this direction, like, you could give that kind of information on the serial output.
How do we 3D print this?
I think you want to 3D print these two parts and not 3D print that part.
What I did here.
Maybe not even print the cup part, like, really the bracket is the important part, I feel like. Like the piece that goes from this through that and into this, I feel like that's like the piece that is. Because these you could find like pieces of plastic from China that you could buy like 100 of for 2 cents each, and it's not worth printing that, you know. But the bracket, that's super custom for what we want to do. So that's the piece that we should print out.
I have a feeling that the real key is going to be getting the software to work, because we're going to want to print the 3D ranging into the room.
Yeah, well, I don't know. How does the parabolic dish change the way that reads distance? It doesn't read the dish as, it doesn't see the dish?
All it does is focuses the
Okay,
chip.
so it won't see the dish as being there. It won't tell you that you have an obstacle 3 centimeters away.
No,
Gotcha.
that would be bad.
Yeah, obviously, it would not be helpful.
If it does that, then we have to back to the drawing board.
That's probably one reason a printed dish may not be the best option.
Yeah, no, you
You
don't
could
want
see that as an
to
option.
range
Just
the range to the dish. No, that wouldn't be good.
yeah.
Would not be good.
Professor,
Yes, sir.
So we can go over it first.
You're done.
Okay.
You're done. Unless you want to play around with some servos. Add more servos. Add an ultrasonic sensor. Do something else.
so, yeah, let's go through it. So, you're including the library servo.h, right? So the important thing about that is what that's
You
doing
guys
is
get everything
wrapping
working?
some
All
of
good?
this
It is
stuff,
working.
right?
All right.
So one of the
And the
things
servo's
in
not
this code is we never did like in
Okay.
row 9
Okay.
or whatever, right? Like
I built a little robot
That's
arm with
because
these servos.
you named
Servo.
your servos. You said, you know, I'm going to start.
servo
I
arms built with
want
the servo,
three objects,
Including the
servo
servos,
objects,
about $20.
and I'm going to call it servo 9.
Price break.
Is that what this shield is doing?
So the shield is really just to make connecting it easier,
Oh, okay.
right? So you could connect that right to your Arduino, and it would make no difference at all whatsoever,
So,
as long as you connected the signal pin to whatever digital pin you're using, pin 9, and then plus 5 volts, and ground to ground, it would be identical. That's just purely for ease of use, yeah.
Okay, Professor.
Thank you.
And so you're creating your servo object, you're gonna call it servo 9, and then you're telling the library that you're attaching servo 9 on pin 9, and then it does your setup already. So it's gonna be like a pin mode, whatever it's gotta do it.
So we got the servo.
And then you move on to the loop, and so one of the functions in the servo library is the dot length. So that's giving it an angle from.
Josh, is everything okay over there? You got any questions?
I think that one is.
This is supposed to rotate 180 degrees.
I think it's.
I know.
So those cheap
You're okay?
ones usually
I'm a
go-
little bit confused on how you're using Tinkercad, but I'm just watching the videos.
Nicer ones are 180
Lab 3.
rotation, but that's just like one of those little.
I'm sorry, I'm not hearing you.
So yeah. you-
Yeah, I'm gonna turn up the volume here.
They always are gonna have slightly
Okay, go ahead.
values, max values,
This is lab 3, right?
the way they're.
This is lab number 3.
All right, yeah. So I'm just watching the videos because I'm kind of still a little bit confused how you use Tinkercad, but I'm all right so far.
All right. Well, I'm here in case you need me. A lot of people have just set it up, got it to work, and left already. But if you want to, I can run through the Tinkercad.
That would be great, actually. Just give me.
All right, let's do a little Tinkercad, shall we?
That's not full circle. It would if it was a 360-degree circle. But so since that circle is only capable of, say, 150 degrees, it looks like it's going to rotate 150 degrees in its dock. That's its max rotation. No, it'll stay there.
So we'll
It'll
start
stay
from
there.
scratch,
When you
right?
hit right 0, it'll go to 0, or at least as far as 0 as it can. Maybe this circle can go to 20 degrees, but it'll go as far as it can.
So this.
And then what we'll do is we'll look for an Arduino.
It's looping through every position, yeah. So you're saying first, put it at 1 degree.
Grab the
Delay
Arduino
50 milliseconds.
and
Then put it at
put
2
it in
degrees,
place.
delay 50, and it's just looping through
what
180
we'll do
degrees.
is we'll get
Then it's
ourselves a
resetting
servo.
back to 0.
And the delay is like the time that it takes.
And here's a little micro servo. And we'll put
Exactly.
that in.
So the reason that he's putting that delay there is because in reality,
And then what you want to do is you want to get your 5 volts.
And if you could just do this for loop without any delay, but that circle would just be constantly moving. It would never catch up with your commands, right? Because this Arduino code can run faster than that circle.
Okay.
Goes to the middle.
I was just trying to like.
Yeah, totally.
Get your ground.
No, totally, and it's better to figure know why you're running something that you're running. So now, right, let's try reporting your position
Goes to the
back to you, right?
Put the ground.
We use the
We'll color
serial
it
line
black.
already. So you heard him talking about baud rates.
And we'll
yeah.
color this red.
Right, so we're gonna use that really quick. So in your
Then we're gonna
setup,
get pin
right after
9.
that line, add serial.begin. .begin.
But then into the signal,
9600.
color it
And
orange,
you're
so
gonna
it's
need to
consistent
capitalize
with the
S
servo.
for serial as well.
And that's your wiring. And that's all you need.
And then you could go here right before that delay 15.
Did that make sense to you, Josh?
So you took the micro server, and then what wires did you say? I didn't hear the wires.
Yeah, so what I did was I ran a wire from 5 volts to the middle.
So it's gonna print out the.
And then I
so now
ran
if you
A
re-upload
wire
this,
from ground to the side.
and you go
The
tools.
servo is colored black, red, and orange. And in fact, that's the way it is in the lab, you know.
Serial monitor.
Black is ground,
And
red is 5 volts,
so there's your.
and orange goes to pin 9. That's your
Yeah,
signal.
as it goes through, that's every single
What do you
one.
think of that? Does that sort of make sense?
Really the best friend in terms of like debugging stuff.
Ground goes to ground,
Like,
right?
plug
So
something in.
Yeah.
ground goes to the black, I mean the brown wire. Red goes
Usually
to
you find out things,
The volts.
but like.
Right.
5 volts.
Having it
Yeah,
say, like,
that's right.
what this is every time you iterate.
and then you said orange goes to pin 9.
And then
Yep,
that's how you
that's
find
it.
out.
And then I just need to put in the code, right?
So
That's all you need. Now all you need is code.
It's usually your tool to help you know.
Cool.
So that's your baud rate frequency with which symbols or a collection of bits are being transferred between
So this
the
is,
serial
I have
voltage between the Arduino and the
and
computer.
here's my code.
Why do you pick that?
First, I'll show you the simulation,
The
okay?
most common rate is
Here's the simulation.
low, that's just generally like, so slower than that, like it's gonna be slower, it may be slower than you want if you're doing something relatively fast. Really fast stuff, if people are doing like radio frequency or Wi-Fi based stuff, they'll use like 115, 200,
This is not.
right? Way higher.
And with that.
Something
Let me
happened
answer
here.
this really quick.
My code got messed up.
Well,
Let's try a different one.
I don't even extend the warranty.
That's fine. So, it's a 9600, is that just gonna print out the serial number and packet?
Yeah, well, so if you had 115, 200 versus
That's my
9600, 115,
Let's start
200,
the
which is a much
simulation.
larger number,
Now it's
it
working.
will be faster. Now, it
Now let's look
won't,
at the code, and that's
you
it.
won't always see things faster because how fast you see a message is often actually dependent on.
Josh, can you see the code okay?
Right?
It's kind of far away.
It's kind of far
It doesn't
away.
matter that your
Yes, it
serial,
is.
for
I tell you what we're gonna
transmitting
do.
fast because your loop isn't moving that fast.
Let's
Right.
take the code,
Exactly. So when it becomes helpful is when
Copy it.
your loop is moving really fast.
and then what we'll
and
do
you
is we'll
want
throw it
to-
into
you
the
want to
Arduino
get the output
IDE.
before anything else happens, really fast, right?
If I didn't have a delay for these, then I would want.
Maybe. I mean, in the case of the servo, it's probably always going to be fast, to tell you exactly what's going on. Now, maybe with no delay at all, it's have a hard time keeping up because it's going to be continuously rotating. But at that point, if you were continuously rotating, it probably isn't efficient to try to measure it at every single point you can, because then it's just going to.
Now let's increase
It's
the
just gonna
size.
tons and tons of
Control.
processing power. So like, maybe if you're in that position, you want to think about like measuring it less often and using those values in a
Increase the
way.
size.
Okay.
Right.
Plus.
That's not to say you couldn't use a higher baud rate to capture it, but sometimes it's not really worth it, but sometimes it's necessary. if you're
Is it easy enough to see now?
back, right?
Yeah, it's better, but it's kind of like faded, but I can see it.
Reaching with a little chip on an Arduino as well, like a remote controller, you gotta know instantly.
Just a picture of it. Okay.
But 9600, like, that's so fast. Like, that's really fast. Like, that's really fast. Like, which is why it's fine. It probably would always be fast enough for something like mechanical like that. Like, when you're talking like waves and stuff like that, you know, like, then you want to be really high because you're talking radio frequency, stuff like that. Like, that's crazy fast. But,
I'm telling you, I don't know how to change the font color. But if you can see it okay, maybe that'll help.
Yeah, it's fine. I can see it pretty.
No. So there, it's like.
I can run you through the code if you want.
I'm just my,
Servo.
Try to make it go above.
Say it again?
my code doesn't have the servo on top. Does that matter?
Yeah, you gotta have a servo. You need
So I gotta
to,
write it in.
you gotta include it.
Is that a hashtag include?
Yes, it is.
You know, continuous rotation servos are 20 bucks.
Servo.
You're not buying, you know, from Asian waiting a month and a half right now with how bad the wait times are with customs. Like, so those, the continuous rotation metal ones, like they can be expensive, but those, you know, you can stay here a couple bucks. And sometimes that's all you need. Sometimes you're flipping a light switch and it's like, all right.
Here's the servo sweep code. You can get that right out of the example.
Relatively simple. I think that those are, they just use like little molded plastic pieces.
I'll just reduce the size so you can see more of it.
You probably could, but the problem is when you really want metal.
So here's a servo that's right out of the example.
And the metal gear ones.
So if you take this servo,
They CNC on those.
copy it, and put it into Tinkercad, it should give us something. Let's see if that works.
Yeah. So and you.
So here it is sweeping back and forth.
Yeah,
So that's
there's
just
tons of other
code
good
right
stuff
out of
you
the
can do
example,
with
Josh.
Those with servos. Servos are nice. Like yeah, like servos with gears.
Okay, can you go back to what you had before?
Actually,
Yeah.
like translate servo into a linear motion device by using a couple of gears. So that's something that you see sometimes with servos, just to slide something forward an inch. The servo can actually do that by using a gear that just pushes a linear shaft, right? That has.
Is that all right?
Yep, that's fine.
Yeah. Yeah, exactly. That's just doing one side to another. Like that's basically servo basic. Maybe it's a bipolar motor, but that's gonna be it's just rotating and rotating. Oh, so that's with the ultrasonic sensors that we used last week, where we're gonna put those on servos, hopefully with like a dish or something, so that we can like try to rotate them and like detect detect things around in like a rotating fashion. Let's see if we can do that on the labs.
Josh, can I go to a different screen now? You got this?
I just need like another minute real quick.
Okay.
Up and down.
I'm glad it was a short lab.
Yeah, sure.
Short labs are better.
Sure and sweet.
You know, it's enough to
Well,
get
it's
people.
really easy with a few people because like you get it figured out.
Well, the other thing is like, you know, what's the point of having a port to people got the circuit work, that's good enough.
Yeah.
They got the upside to work, it's good enough.
Yeah.
And then maybe what we do is I'm not thinking it's
Oh, yeah. Yeah, no problem. And I did find orders and notes if we did get more, you know.
Professor.
I'll be right there just a minute. Yes, sir.
Mine's not doing what yours did on my with the code.
It's not.
Yeah.
Where did you just type the code in?
Yeah.
You did # angle bracket servo.h angle bracket.
# angle bracket.
Yeah, you see the angle bracket up there? I don't know if you could see it. I wish I could join Zoom with this desktop computer. Then I could.
Yeah, I could share my screen, I think.
Yeah, go ahead.
You disabled it. If you can enable it, I can share my screen real quick.
Okay. Let me see how I can do that. Okay, go ahead, share your screen.
Okay. Can you see my screen? This is what
I can. I can. So it looks like you've got everything correct. But it doesn't work.
I just start the simulation and it doesn't turn like yours did.
What if you click on the code?
Thank you.
Yeah, it's not turning. Oh, thank you. All right, let's look at your wiring, shall we?
Okay.
I can't see it too good. Can we zoom in? Are you sure you're hooked to 5 volts and ground?
Yeah, ground to ground.
Why don't you color code your wires?
Okay.
Click on your wire and make your 5 volts, make it red.
That's my ground.
And then take your ground and make that black.
All right. Black.
Well, it looks like you got 5 volts to the middle, which
Yep.
is right. Yeah, it looks fine. It looks fine. I don't know what you did.
Neither do I.
Huh. Tell you what, I'm going to share my my project with you.
Okay.
And you're gonna and that should help you. So let's do that. Can I how do I send an email? I can't remember how to send an email from this computer.
Can I stop screen sharing? Is that good?
Yeah, you can stop screen sharing. Shoot me an email and I will send you an email from home because on this desktop computer I have in the lab, I don't know how to set it up for email.
I also sent you another email explaining why I couldn't be in class today, like earlier.
No problem. I'll send you an email after I get home a little later on this afternoon. Is that okay?
Yes, fine. So you want me to send you an email and then say, what do you want me to say in it to remind you to
Yeah,
say?
just say I had a little trouble with my Tinkercad, and can you help me out?
Okay,
And I will help you out. Okay.
that's good.
All right. Let's. Everybody's left already, it seems. So I'm gonna sign off,
That's fine.
and I'll pick this up a little later on today after I get home. Okay.
Yep, no problem.
All right. Thanks a bunch. Stay safe.